Hi, morning everyone. Thank you so much for making it. So you already know me. I know everyone here in the room, almost. And mainly my colleagues did ask me to put a presentation together to speak about blockchain and to explore with the experience that I had. I've learned about blockchain for the past 2.5 years. So I've been working in that space for quite some time already. And I want to share with you what I've learned so far with most of you, actually. So in the beginning, I will speak about some background, timeline, how did it all start, and I will then go off what does it really solve. I will take that, and then I will emphasize of when it's a good idea to use blockchain, and how does it work. We will go over some PowerPoint slides, and then we'll go over a demo where we can present with a hands-on experience how that blockchain thing works. And then we will go over some research result that Yiba and I came up with. We came up with a definition of the blockchain, of how the industry defines the blockchain rather than how the academician defines the blockchain. We analyzed around 4,300 companies to come up with that definition. And then I will share with you some experiments that we are currently doing here at the University of Scranton to engage our students into a more creative way, using cryptocurrencies and blockchain. I will also share with you an example where IBM and major companies are implementing on a global level for food supply. So that's another dimension. Then I will highlight some challenges within that space, and we'll wrap up for questions and answers. So as a timeline, as we see here in the beginning, it started in the late 70s, early 80s, when the cyberpunk movement of free software was at its peak, and people said software should be free, internet should be free, and that led to Napster a few years down the road, where peer-to-peer technology was really something important. But down the road after that period, in the late 90s, the email spamming was a serious problem for most of the individuals. So what we started to see is attempts to solve that problem. Hashcash occurred at that time, and the proof of work concept started to surface, which means if you want to send me an email, you have to spend lots of energy to send that email. That will deter you from sending me spam email. So that was the idea. On a parallel line, the money market was starting to think of financial tools to make transactions online, whether anonymous or non-anonymous. That was prior to the boom of the internet, when transaction is the norm. So at that time, a number of technologies occurred, like DigiCash, B-Money, BitGold. All of those companies died already. That was prior to the boom of the internet. Then, down the road, the private-public key infrastructure started to be more established. And at that case, individuals can start to trust each other online with defining that, yes, I am the one sending you this message. It could be proven with cryptocurrency and cryptography. Fast forward to 2008, a paper was published by pseudonym Satoshi Nakamoto, which is either an individual or a group of individuals, nobody knows. And they said, let us use all of those technologies to solve one specific problem, which is double spending. What did that mean? It means that if I want to give you $500, there was no technology at that time to make me say, okay, I will give you another $500, but I don't have that money in my bank account. We needed a third party to trust us so that it can validate this transaction. So they said, well, we will provide a technology to solve that problem. That was the beginning of the blockchain, and the application was Bitcoin. Most of us have heard of it. Fast forward down the road a few years back, in 2013, that blockchain technology was pushed even further for contractual agreement to take place. So this is the general highlight. So smart contracts, ICOs, billions of dollars spent, invested, a new thing is happening in that space. So mainly Bitcoin is an application of the blockchain. It is not the blockchain. It is the result of a number of technologies, including peer-to-peer technology, public-private key infrastructure for cryptography, and a consensus mechanism where a group of individuals or a group of engaged parties, mostly machines, have a consensus on a solution, and that will be the truth to apply it. So what does it solve, really? It solves the major concept of trust. Fundamentally, in Bitcoin, the double spending option is I cannot trust you, so I need a third party to give me the agreement that you have the money that you will send me. So I need a bank, right? But based on a framework where machines need to spend effort and energy to perform something, and a group of them agrees on that, that removes the need for a third party to approve if there is a consensus among the group and each one has a stake. So it solves somehow the trust issue. So let us look at the example where Alice and Bob, they want to have a transaction, basic normal things, no problem whatsoever. So Alice wants to give Bob $500. How? If she sees Bob, she'll give him $500 and that is that. But today, what happens is, as you see here, I need a third party, trusted third party, and that will be using a bank or something. And that will take maybe a few days after the bank takes some fees. So when to use the transaction? We use blockchain when we need to eliminate that third party, that trusted party. If we want to fix the double spending problem without a third party, do it faster rather than few days, I want it in few seconds, make it in a more secure fashion. I can trace that history and I cannot delete that history. If those are things that I need in my solution, then maybe blockchain can be a way for me.
One question.
Sure.
When you say double spend, can you clarify that?
Sure. So the double spending problem here means in the online domain, if I don't have a third party, there was before blockchain no mechanism that is widely enough approved that says I can guarantee that party A will not reuse its same money to buy multiple products, and nobody would know that I have the funding or not. There was no existing mechanism at that time without either Visa, MasterCard, or a bank that validate that I have money in my account. So at the internet, one of the things that prevented a peer-to-peer trusted network where we can send value to each other, that technology did not exist or was not placed together. Double spending is an act where I'm spending the same money multiple times, and there is no one who can trace that back to me. Does that make any sense? So let's say I have $10, right? I'll give it to eBay, $10. You don't know that I give eBay $10. So I'll give you also $10, and you'll give me a product. Now, at that time, prior to blockchain and Bitcoin, you didn't have a way to validate that I have the $10. You didn't know that I already gave that money to eBay. So I could perform a double spending and commit fraud, literally, by sending money to multiple individuals without being detected. So that was a problem for the online space. And Bitcoin solved specifically that problem. As they solved it, that mechanism of blockchain that I will explain in a little bit showed so many opportunities.
Ahmed, would it be something similar to transaction fees offered by Visa or MasterCard? Would that qualify as double spending or no?
No. The transaction fees for Visa or MasterCard, I am a merchant. I'm using my payment selling point. I'm using your card, and I'm charged 3% to pay to Visa or to MasterCard. This is not what the double spending is. The double spending is, as an individual, I can pay the money to someone, and then I can claim that I still didn't spend that money and pay it to someone else. and receive multiple products by saying that I have the money, I didn't spend it. So it's a clearance issue.
I think it is kind of a promise to make
A promise to
the same
payment.
amount of money
Yes.
for multiple products
Yes.
instead of making payment.
That's correct. And actually, in few slides, I'm having an articulated example that hopefully will clarify that point a little bit further. So how does it work? Alice has $500, the double spending issue, right? So this is a public ledger, and blockchain says it's public information. I have $500. Everybody knows that. Everybody sees that. Now, Alice will give Bob $500, and this is recorded on a new block connected to the prior block. I had the historical dimension of this. Then Bob sent $400 to Carol. Bob can't send the $400 to Carol because he already got $500 from Alice. And then Carol is spending and giving $300 to Dave. Now, I can trace all of that information back. I can look at that document and say, oops, this is my blockchain, and they are traceable together. Now, all of those connected nodes, if Alice attempts to have a double spending and give another $500 to Dave, Alice will not be able to do that, because someone can trace and say, hey, Alice, you don't have $500 to give to Dave. And this is something that was not possible before 2008 by having it in a public fashion. But there is an important aspect that is missing here. In the blockchain, one of its objectives is not to have any intermediaries. So for not having any intermediaries, here, what can we do to do that? A bank can do that, right? A bank can be the trusted one that says, hey, Alice, you cannot pay Dave $500 because you don't have that in your bank account. So the blockchain said, okay, let's take that record, that public record, and have it at multiple individuals having a copy of this. So the question that sets itself is, why host a copy of the ledger? Why would Alice even care about that? We need to find a solution. And how to update that ledger, right? We need a way to automatically update that stuff.
One
Sure.
don't mind. What happens, Bob has already have $1,000 prior to getting into the blockchain. Then these peers in the chain, they will not know his previous balance.
You cannot do that. Again, as we will see that in a minute, you will realize as we do the hands-on demo, you cannot be a part of the blockchain before stating first how much did you start with. So your ID will know, we will know exactly, each one of us, how much have in terms of how much do we have in our wallet. So that will not be the case. Please.
And it's peer-to-peer as opposed to...
It is peer-to-peer. It is not centralized.
It's a bank or anything.
No.
Everybody has a ledger.
Everyone has a ledger. If you want to have a ledger, you have the right to have that ledger. So this is your total right to have that ledger, yes.
No, when he is saying even peer-to-peer, Bob has to declare all his assets.
Yeah.
Or,
Public ledger.
what I'm trying to get it is it only specific transaction-based product? Or is it the entire history of these people who are participating, the peers who are participating? What about their prior assets?
Only I see what you have posted on that blockchain. I do not see what is outside that blockchain. So the system, the ecosystem, is only seeing its constituents, is not seeing anything outside it. Please, Anne. Yeah, Nancy.
So at the end of this transaction, Bob has $100 left, Carol has $100 left, Dave has $300, and Alice has $0, correct?
Yes.
Okay, but no one's paid any fees because they're participating in this blockchain?
Oh, no, the fees section is coming in a little bit. Yes. I'm just trying to pass the concept a little bit easy, and then I will hit the fees piece. Yes. Yeah, there is a fee. Oops. Okay, so let's see here. Let's say Bob wants to give Dave $100, right? It's unconfirmed transaction. someone needs to get to the work, right? Someone needs to validate this transaction, make sure that in my record, Bob has $100 and Dave actually exists, and that transaction needs to take place. So this is where the miners come into place. So those miners here, what they do is they, I don't know how to. Those miners here, what they do is they try to check if Bob has funding to be able to give it to Dave, and if Dave even exists. So to do that, miners, mainly, they are special nodes. Anyone can be a miner on the network that validate transaction and add it to the block. So let's say I want to validate transaction on the blockchain today. Easy. Go online, download a block, start validating. Go ahead. That's totally fine. No problem. Please.
You say the miners are checking to see if he has the funds to do the transaction. Are they actually checking the bank account or checking, what are they checking?
Okay. Every miner has a copy of the entire blockchain, right? So in my blockchain, let's say I am a miner. I downloaded the entire blockchain, Bitcoin, let's say 150 gigabytes. So 200 gigabytes. I will download the 200 gigabytes on my machine. And I will search, okay, does Bob have any money? If yes, does Dave exist? If yes, can I validate this transaction? Good. After grouping a number of transactions, I will put them together and I will do some work. And whoever answers first will be rewarded. So where do I do that mining? I do it on my own computer. And once I find the answer, I disseminate the answer to everyone else. If everyone else agrees on my answer and can prove that my answer is correct, then they will add that block to their existing blockchain on their local machines. So actually what happens here is, as a special node, as someone who is downloading that block, you will validate your transaction. A few years back, you could validate some transaction, mine 200 blocks in a day. Today, it will take you 15 years to mine one block on your personal machine. So you need special equipments, big machines, to be able to do the work and mine that transaction. Look at it this way. Those miners, any one of us can be a miner right now. We all stand in a line, right? And we have 10 minutes to find the right answer. We all run very fast. Whoever wins and get the answer first gets around 12.5 Bitcoins. How much is the Bitcoin price right now? Multiply that by 7.5. That's what you make. So actually, every 10 minutes, someone is making tens of thousands of dollars. That being said, so we compete. Once someone finds the answer, usually it's within 10 minutes, the race restarts again, and everybody runs and gets rewarded. Please.
It's not one miner that's validating a transaction, right? It's thousands, or is it?
I will show you right now where are the miners existing. But yes, the miners validate the transaction, and they combine them together into a block, and then they create a mathematical equation on the block, and they get rewarded for adding the block plus the fees as a part of the reward.
What technical skills do you need to have to become a miner?
You need $5,000 to buy a hardware. You need to be able to download the code, power up. It works.
So you don't need any
Technical skills.
You don't need anything. Just
No,
the equipment.
just the equipment.
Follow some steps.
Yeah, there is a code that keeps running. And whatever that code, it's a random. So you keep, and we will see now how we mine a block. So in a minute, I will show you exactly how a block is mined and the amount of effort. It is just a random generated number, brute force, one-way algorithm. So you don't have to know the algorithm. It will work for itself, by itself. Please.
Can a miner make a mistake? You say confirm and add it to the block, suppose they confirmed it and it was wrong.
No way, impossible. Impossible. I will show you now exactly in a live demo that that's impossible.
These are in the miner software.
Yes.
So you were saying that you're replacing intermediaries,
Yes.
but in a sense, now there is an intermediary, but you don't know which one. They're all competing
Yes.
to find.
Anyone can be, you see, there is a fundamental distinction here. As an intermediary, I have to go to Chase and say, okay, you are my bank. I have to go to my bank. Here, any one of us can become an intermediary. There is no specific third party. So, please.
So, and maybe you have the answer, but if everybody's working off of the same algorithm,
Yes.
then basically the power of your machine is what is allowing you?
That's it, the power of the machine. You have to put money in it to get money off it. Usually the amount of energy that is consumed on a daily basis is less than the amount of rewards by around $1 million. But at the end of the day, lots of people spend the money. So there is an equilibrium so that there is no inflation in the process.
Yeah, currently many miners have closed their shops.
Yes.
Running large.
Yes.
So to say, whoever has.
Because there are a lot more people using, so they get a,
Going back
Small,
to
multiple
Alice,
people get it, you get a miner to buy the coin.
she starts out with $500.
Correct.
Where does that come from? Where does it go to start off the chain?
Sure. We will see that in a bit. To have the Genesis coin, the beginning of it all, right? Let's say I'm starting my Bitcoin today. I will have to create my Genesis token or my Genesis coin, and then I will start distributing that to a number of us, and then we will distribute it to others if there is need for it. Down the road, I will show an example, an actual example, which we implemented here at the University of Scranton, where we created our own money and we started distributing that, and we will see how that money evolved to create value within an ecosystem. So Alice, how does she have those $500? She says, I have 500 coins. Now, if that coin is equal to $500, I can make that exchange and I can send that value. But what I have actually on the blockchain is a coin, not an exact US dollar. Does that make some sense? Okay, please.
So, I'm still trying to get to grips with what is it that drives the value of Bitcoin?
The value of the Bitcoin mainly is created from the demand. Let's say I have $10, right? I'll give it to Vince, he'll give it to Steve, to add to you. Now, that $10 became $40 just because of the transfer between us.
So what drives the demand?
The demand is the ecosystem that you create. So if you create an ecosystem that have a request, so for instance, here at the U, when in our Wayne house, in our business incubator, when we ask our students, do you want to have a space, an office space to start your business? That's fine. You need to give me some coins. How can I get those coins? You need to attend this class to get some coins, and then you will pay me those coins, and I will give you that space. So before you know it, you create a demand. You efficiently create the demand as using it as the own currency within the ecosystem, and that creates value. The higher the demand, the higher the value. And that's what, the same concept why the dollar is more expensive than the yen. It's demand and supply. There is no backing. It's based on the number of transactions. Yes?
It's just like, the price of a stock with Bitcoin, it's supply and demand and expectations, right?
Supply and demand and expectation. Definitely there is a dimension of speculation when it comes down to the pricing. But in actuality, if you want a pure ecosystem, it comes down, do I need that? If I need that, then I will ask for that token. So you want that service, you need to use this token. Here is the demand. If there is too much need for that service, the value increase. Yes? No? All right, let us continue. We will start seeing things a little bit clearer when we do that manually. So Alice gave Bob, Bob gave Carol, Carol gave Dave. We created the blockchain. We removed the intermediaries. We have our blockchain on our own machines. Now, if we want to confirm a transaction between Bob and Dave, miners comes in place. They evaluate this transaction. They validate that Bob have money, Dave have money. They find the answer, and they check the blockchain if Bob has enough money to send Dave, and they try to guess a number of for adding a new transaction on the blockchain. So this is a guessing part. It's just a chance, right? And then once a miner guesses right, and he is correct or she, they win and broadcast the answer to the network. Everyone else stops to try to validate a new coin. So now you will find the blockchain, it's every 10 minutes. You will find the Ethereum every 30 seconds. Every blockchain has its own condition. And we will see that in a little bit. So what do we know so far? We know that a blockchain is based on distributed public ledgers. Miners compete with each other to validate transactions and add them to the blocks. And miners that win the competition gets a reward. And today it is 12.5 Bitcoin every 10 minutes. So this is how much they get. Okay, so this is to here. So after the double spending process, smart contract started to evolve in 2013. Today, we have $18 trillion every year of paper transaction system that is available. And smart contracts, mainly what they do, they have the ground rules. What are the basic details of the contract? Distributed network of nodes execute contracts and monitor the compliance of that contract. And the outcomes are automatically validated without any third party. So you and I, we can have an agreement. We can have it into programming language. And that programming language is online. Nobody can fake it. It is historical. It is permanent. And it can execute on its own. What does that mean? It enables peer-to-peer trading without third parties, everything from renewable energy to automated hotel room booking. I am dropping the middleman. So I am changing everything. I am changing literally everything.
So when you say smart contract, it means these are the conditions needed to execute the transaction, like a price, or you will deliver me X quantity
Yes.
of this material of this quality to this.
Yes.
And that is coded as conditions.
That is correct. So before moving to this one, I will share with you a 2-minute video to wrap it up together, and then we will continue to the next step. So this is, again, this slide and those slides are from a number of sources that I used from online. And this is one code that I've read, and it makes too much sense. It's a new era from information exchange to value exchange. So internet is information exchange. Now we are capable of exchanging value. That was not possible before. And this is where I think there is a major distinction. So before going into how the industry defines it, let me share with you here a video. It's a 2-minute video.
If you meet someone online, how do you know they're who they say they are? When you buy coffee that's labeled fair trade, what makes you so certain of its origin? To be sure, really sure, about any of those questions, you'd need a system where records could be stored, facts could be verified by anyone, and security is guaranteed. That way, no one could cheat the system by editing records, because everyone using the system would be watching. Systems like this are on the horizon. A software that powers them is called a blockchain. Blockchains store information across a network of personal computers, making them not just decentralized, but distributed. This means no central company or person owns the system, yet everyone can use it and help run it. This is important because it means it's difficult for any one person to take down the network or corrupt it. The people who run the system use their computer to hold bundles of records submitted by others, known as blocks, in a chronological chain. The blockchain uses a form of math called cryptography to ensure that records can't be counterfeited or changed by anyone else. You've probably heard of the blockchain's first killer app, a form of digital cash called Bitcoin that you can send to anyone, even a complete stranger. Bitcoin is different from credit cards, PayPal, or other ways to send money because there isn't a bank or financial middleman involved. Instead, people from all over the world help move the digital money by validating others' Bitcoin transactions with their personal computers, earning a small fee in the process. Bitcoin uses the blockchain by tracking records of ownership over this digital cash, so only one person can be the owner at a time, and the cash can't be spent twice, like counterfeit money in the physical world can. But Bitcoin is just the beginning for blockchains. In the future, blockchains that manage and verify online data could enable us to launch companies that are entirely run by algorithms, making self-driving cars safer, help us protect our online identities, and even track the billions of devices on the Internet of Things. These innovations will change our lives forever, and it's all just beginning. To learn more about the urgent future of the blockchain.
So how does the industry define blockchain? So Yibai and I, we analyzed 4,300 companies that already generated more than $20 billion in the past 2 years. And we came up with a definition, and that says that the blockchain is a decentralized peer-to-peer technology that uses the proof of work, among other models, to reach consensus and enable new economic business models in different industries, including advertising, banking, and energy, to name a few. What does that mean? It means every company that solicited investors, that collected money, 20 billion in 2 years, this is a major amount of money, way bigger than venture capitalists, what they did in that period of time. So best than any crowdfunding application. So there is definitely a significant thing here. And what we did was we collected how they presented their understanding to solicit money from investors, and we used semantic analysis, latent semantic analysis, to understand the content of that. And the output was this definition. The industry sees blockchain, not how we see it, how the industry sees it, as a decentralized peer-to-peer technology that uses proof of work among other models to reach consensus among each other and to enable new economic business models. This is fundamental, and the number of economic business models are so large, we selected a few examples here in our definition. So let's go for the demo. Let's see how it works, right? So the first part is the ingredient. So here you go. A SHA-256 is a cryptographic algorithm that will always lead to a set number of characters. It doesn't matter what I insert, it will always give me the same number of characters. So if I type in my name, it will give me a number of characters. If I add a space, new set of characters. If I do an enter and I type in University of Scranton, OIM, right? If I keep typing any information, it doesn't matter. The entire encyclopedia, Wikipedia, if I insert it, it will always give me that. Now, it's very hard to figure out whatever I wrote based on that number, but it's so easy if I know whatever is written to come up with that number. It is a one-way brute force algorithm. So this is how I am okay to give whatever number, and I am confident that nobody will figure out what is the content. This is where the privacy is. So this is one of the ingredients of the hash algorithm. I can put whatever information online. Nobody will know what's happening, right? I can type in Ahmed, or I can type in Yibai, or I can type in Ed. Good luck knowing. You have no idea, right? So this is the first part of the ingredient. The second part is putting the blocks together. So in this block, whatever the block number, the nonce, which is an ID that people are trying to find, and whatever content inside will give me a hash value. Let's say a new transaction came, right? So here is transaction 1, and then transaction 2 and 3 and 4. So as we add transactions, okay, this is the size of the block, it's time to add it to the blockchain. All of us, as miners, we will try to figure out what number that will give me a hash value equivalent to the first 4 characters here. So we have no idea. It can be a small company, a big company, we are all racing. So we get our machines to work. It will take us a few seconds as the machines keeps trying, and bingo, here we go. This is equivalent, plus or minus, to a hashed function. So it is accepted within.
Would you say Ahmed is taking only 4 characters to actually get the code?
No. What I'm saying here is this hash value is the output of the block ID nonce, which is a certain number, and some data. When a block is given to the miners try to figure out the proper nonce value that will be accepted and will generate an acceptable hash. So whatever content it is, it can be 4 transactions, it can be the entire encyclopedia, it doesn't matter. What matters is trying to find the number here that generates the right output. This is only for demo purposes, but how hard it is, I have actually an exact number. It can take you 15 years on your personal computer to figure it out, that number, as a person, to figure out one block hash. So it is not that trivial, actually. It's more. This is only for demo purposes. So once we have the block, we can connect those blocks into chains. So in this one, in the first block, it has a hash, 4 zeros, and then it is connected with the same hash as previously, and then combining all of that with the previous hash gives me a new hash that is equal here, and so on and so forth. And this is how the blockchain is created. So once we mine a block, we can add it to the chain, and it will look like this. If we add any value here by inserting wrong information in our blockchain, let's say you gave me $10, and I want to say that you gave me $0, right? It is recorded on the blockchain already. So I'm changing what you gave me on the blockchain, and I'm making it, instead of $10, $0 or $1, right? So I changed this one. What do I need to do to make that happen? I need to recalculate the equation so that I can find the new hash that is equivalent, and I say yes. So I have to make more work, and I'll have to spend energy and consumption to mine this block. And because this block is connected with the other block, I will also need to mine this block. So I'll have to do two things. How often are blocks added? Every 10 minutes. So if I want to change something that happened 2 hours ago, I will have to fix all of those blocks. The problem of that is it is not just one blockchain. It is a distributed set of blockchain. So let's say in my blockchain that I downloaded, I want to fake the $10 that you gave me. I want to make it $1. So here, and that happened just 10 minutes ago. So I said, no, Nabil didn't give me $10. He gave me $1. So I will fix that. So I will mine this one, and then I will mine this one. The problem is that those hash functions are not equal to anyone else. So all of the other machines who have downloaded the block, they have a different value. This is why it's very hard. Actually, the blockchain of Bitcoin has been now for what, 11 years? It was never hacked. It is the only database that is public, that any one of us can download, and no one of us can change. Everybody have access to it. We can download it right now. No one can change it, even that it is in front of our own eyes, because of that model. So people need to spend so much energy, this is the proof of work, and have a consensus mechanism, and this is how people can trust that this block is correct. And this is how trust is created. So with that framework and that mindset, the second part of the equation is, okay, I want to transact. I want to do something on this blockchain. How can I do this? I need an identity. I need an ID. How can I have an ID? I already went to MetaMask as I was preparing, and I downloaded a plugin. So literally, you can go to any digital wallet, and you can get an extension. And as you get the extension, it appears here. And I edited my account. Here we go. Now, I can see myself. I have an ID. Let's create a new account. I will create a new account, and I will call it Nabil. And I will create. Now, neither Ahmed nor Nabil have any money, and we want to transact. We want to do money on that blockchain. How can we do this? Well, I need money. Nobody will allow me to act with me before getting some rewards. So let's get some cash. Here, I am on the main network. I will switch to a demo network, and I will deposit some money for Nabil. And I'll go for a test faucet. And in that faucet, I will say, OK, give me an Ether. OK, it says, OK, do you want to have this transaction? I say, yes, please. OK. This transaction did not work. Okay. Insufficient fund. Oh, here, okay, so here I will reject this one. I want to deposit from my faucet an ether. Okay, so that faucet somehow is giving me an error now. Okay, so let me try another faucet. I hope I can get a faucet here. So we're giving away every 60 seconds. Ah, no. Okay, so the faucet, the sample faucet is not working. But the idea here is when you request funding from the faucet, you will have some fees to be paid, and the total will be paid. And usually that happens here. Okay. So let me try with the other account under Ether here. If I'll deposit faucet request is giving me an error. The idea was to show you here what kind of money do I have. Since this one is not working for this demo purposes, I will show you what I had before. So if I go to, assuming that we placed some money in our wallet, we want to interact. So we would like to interact on the wallet and create our own cryptocurrency. To do that, let me see. If I can get
I have 0.39. Can I send me your national?
Oh, thanks. This is awesome. Thank you, Ashley. You see, I knew it. Okay, so now I don't have money, right? So now Ashley will send me some tokens, and she will give me some money. Thank you, Ashley. This is great. So yes, sure. So here we go. I will expand that view, and this is my address. I'll copy it, and I will send Ashley my address. So if you can send me a couple of bucks.
Not much.
So your address is your hash.
This is my address, yes. So the only one,
Is your address.
my hash is my address. So no one would know my address unless I tell them that this is my address. It's very hard for them to figure it out, right? I need to say it. So I'm waiting now for Ashley to give me some money. I am on the Robstein network.
Merely has sent you some money to a check.
Oh, that's good. so yeah.
One Bitcoin is about 4,000.
You see, this is an example of how many nodes are available today that are tracking Bitcoins. I have 10,000 nodes here across mainly in the US, and all of those individuals are machines that are right now making money every 10 minutes. One of them will win the prize of 12.5 coins. So, any luck? Still pending? Okay. So something is an issue now with the network. Usually it takes 30 seconds. But that being said, you could create your own currency, actually, with this. I will go to, I should have it, good stuff. Okay. Here we go. I have a third Ether, $40. Thank you so much, Ashley. So now I have money, right? So with this money, so Ashley sent me just some money. Instead, I wanted the fake money. Now she gave me some real money. Thank you. So I would like to do something with this money. So what will I do is I will go to this link, Token Factory, and I will say, okay, I would like to create a token where I can give you all my money and create my own ecosystem. So here on Token Factory, I will create a contract. I want 1 million. I'll call it blockchain lecture. And I will have 2 decimal points, and I will say it blockchain lecture. I will create the money. A message came to my wallet telling me, okay, we're gonna do something for you. We're gonna create a contract. You have to give us some fees for this. Give us our money. Now I have money in my account. Okay, it is being pending, and now it is being deployed. So a contract right now is being created, saying that I created a record of a new currency of 1 million that I can never change, I can never increase, and this is my entire supply. I can never reprint my money again. Right? That's it. So here we go. It is deployed. It is confirmed. This is the details. I can see it online. And online, I can see a success that this transaction took place. It did cost me that amount of money. I created a new contract. Who am I? I am a person who got 0.3 Ether from someone and then created a contract. My entire history is traceable and can be viewed. And that contract now is a smart contract. It happened a minute ago. I can see how much balance do I have. I can send money. I can retrieve money. I have money, actually. So how can I use this in real life? In real life, I can have a Wayne house. What is that? As you know, we are ranked number 31 in the nation. We are learning by doing. So what we are doing here is, we have, as you might know, on 912 Vine Street, this building. It's a business incubator for our students. They can come in, and for anyone in our community, they can come in and start their own business. Doesn't matter, you are OIM department, accounting department, engineering, nursing, health, doesn't matter. Come in and you have an idea, we will help you out. But if you want an office, what we are experimenting with now is, you need to give us some coins. We created some coins on the blockchain. We called it the Wayne Buck. And we gave a part of that money to our students to promote the activities to each other. Now you want to come and have an office? Sure. But maybe you want to attend an event or a class or get me a 3.0 GPA, or you want to help other companies with some of your skills, or you want to promote some activities, or you want to barter service with another company. All of those are ways for you to collect those coins. I will be the source of those coins, and I will give you them for you to get my space. What does that do? It creates, okay, I need the space, I need the value. How can I make it? I will be engaged. I do not know of any other way that is as strong as engaging students, as giving them an ecosystem. And the value is way bigger than that, because before, if one of my colleagues tell me, okay, I'll help you out, he will help me because they are nice, but I cannot help you forever. To help you forever, I need a record of that my activities are 1, 2, and 3. There is no way today to accomplish for that. So this is a way for nonprofit to retrain and to extract value, post it, and have a historical record of that. The amount of potentials, I see them as limitless. So as in here, I don't know that there is any other university in the nation that is experimenting with blockchain and cryptocurrency on their business incubator. And our students, some of them, initially, so I started that, a number of students, I gave them some money, each one of them several million Wayne buck, and I kept a lot of money so that I can use it later on. Some of them got a cold feet. They said, that's too complicated, we cannot do that. And others said, yeah, that's very interesting, we want to do this. And as we are experimenting, I think that the results will be a learning experience for all of us. Not only that, here I think we are the only university, in our region at least, that is fully involved in blockchain. I work with almost everyone here, right? Accounting department, OIM department, management department, finance department. We already had publication in that space. It's very hard to find a place here where you will find all of those assets combined together in one spot. So I'm very pleased with where we are so far in terms of integration within our curriculum across different departments and in terms of implementation. Now let us look at another example where big boys play, IBM. So they trace the produce, they trace how it's packaged, they make sure that it's fresh, and they give it to the consumer. It is an actual implementation. It is a real-life implementation. It started with Walmart, and now mainly what they are saying is almost 500,000 persons die every year from bad food. 80% of the consumer goods products use manual systems. 1/3 of our food is thrown away because it is not good, because it's just not fresh enough, unacceptable. And almost 25% of us think that we can trust our food, but the remaining don't. So those are major numbers. Here is a video that shows how it happens on a larger scale, bigger than a university.
The Internet of Things continues to grow at a rapid rate. Sensors and devices are becoming more commonplace to communicate information. In business networks where data such as location, temperature, or other properties need to be shared, a permissioned blockchain ledger can help create a tamper-evident record. This opens up new ways of automating business processes among partners without having to set up a costly, centralized IT infrastructure, and all participants have access to the same data. Let's look at how supply chains benefit when data is shared through a permissioned blockchain. The IoT-enabled package transmits required status information as it passes through multiple carriers. The business contract specifies the conditions that must be met during the shipment from the factory to the grocery store, and all parties must adhere to the terms of the contract. A temperature sensor embedded in the package stores the data locally and sends it to the blockchain through the Watson IoT platform at waypoints upon receiving connectivity. Information is shared across all peers. In this example, both Carrier 1 and Carrier 2 met the contractual obligations and the shipment arrived at its final destination without exposure to excess temperatures. Using blockchain allowed all business partners to access the same temperature data without requiring central control. The result? A happy customer with peace of mind about the food in his or her cart.
Ahmed, one quick question.
Sure, Doc.
I think this example is an excellent one, but behind the scenes,
Yes.
You are assuming there is an ethical component taking place on part of the supply chain elements. An interesting article not too long ago, they showed an example of a big truck, refrigerating truck, and they had sensors to make sure that the food is actually at a certain temperature.
Yes.
But they showed how this can be
Manipulated.
Yes. By putting the sensor in a small little fridge.
True.
And when you are looking,
You are 100% correct.
you're assuming it's okay.
You are 100% correct.
But the big container
Yes.
is actually saving money, so they don't have to incur.
100% correct.
So-
100% correct. You see, and that is a very reasonable explanation. People will try to do malicious activities. So, okay, tell me, please trust me, I'm telling the truth, and then I'm lying. So yes, that happens. How can we detect that? We can simply trace that bad product back to that exact same person. With the blockchain, your record, so let's say I am the malicious person who is changing that, right? And I give you a bad product. You will identify, the consumer will say, hey, this is a bad product. Before, I could not know that it's coming from you. Now, I know that it's coming from you. So I will remove you from my supply chain. There is no way that you will say, this is not mine. If you, please.
How do you know which truck it is?
Oh, I know your ID.
Trucks and one truck is manipulated.
The supplier. You see, it comes, that product is coming, yes, so it will lower my amount. So I will not know, maybe if the details is not zoomed in, I will not know the exact person, but I will be able to track it down to a way that I can do my investigation. So 100%. And by the way, this is one of so many examples that I'm sure that we will learn as we are experiencing with this new technology. And that leads me to
I have one related question on this.
please.
Where are the cryptos used in this? And also you mentioned another thing on the slide, the permission network.
Yes.
It's not a peer-to-peer.
Yes.
Permission.
Yes.
What is that?
Okay, so because of the time constraints, I will be more than happy to do that, but there are different types of blockchains. Some of them are public, some of them are private, some of them are hybrid, so we can speak about that in more details. Here it is private, so that it is only for a set of suppliers. Tokens, it is a currency that we created right now. This is a token. Again, cryptocurrencies are not blockchain. That's another topic that we can spend a good amount of time.
IBM food.
No, we need transactions, so we need a token. Will that token be for sale? No, it will be only used to traceability and auditing reasoning. But then this crypto by itself is another big one that we can spend some good time on it. So what are the current challenges of our, we don't have enough trained professionals. Nobody knows what it is. Nobody understands it. It's new, it's big, it's changing, it's happening, but we don't have enough. We are addressing that here at the U. So actually, most of our departments at KSOM are already integrating that in our curriculum. New technology adoption takes time. We need to have successful use cases. We need to see realized benefits that are happening, and we need to have a wide adoption. Scalability. Bitcoin had a problem that it takes few seconds to do some transactions, while it takes 10,000 transactions per second for Visa. Now, Ethereum is way faster, but still is not as fast. And there are efforts in improving that. Regulatory issues, accountants, taxation, SEC, law, liability, usage, privacy issues, energy usage. So we have a good number of challenges for all of us to think of. And then, as a wrap up for today, it is, we know that blockchain has some potentials. It seems like that. It solves the problem of trust. It's secure, a way for trusting, moving money, product, information worldwide without third parties. It promotes new business models that were not an option before by removing intermediaries. Still have its challenges, and things are changing very fast. Very fast, every other day. Like Nabil said, here I've seen this one, and then another day, boom, a new thing. So the speed is really fast, and it needs a village to be able to understand and create a positioning, being the leader in this region within this technology. And I think we have accomplished that already. I don't know, again, anyone in our 80-mile radius, even 100-mile radius, that have that level of expertise that we already have developed in the past year in KSOM with all of us. That being said, if you have any questions, I will be more than happy to answer them. Please. I would love to, sure, by all means, please.
I think, isn't the biggest problem with blockchain is really, like, why it's not being really implemented is because of scalability?
You see,
with Visa, but you know, how is that going to be changed? You know, 'cause I know, like, Bitcoin was recording everything, like if you bought a cup of coffee, something
yes.
like that. Not all that really needs to be stored on different layers. So isn't there different layers now to blockchain?
There are a bunch of dimensions of research in here. First of all, the consensus mechanism. For instance, I spoke with Christian from the theology department. What is the truth? Is it the majority? Is it those who work harder? Is it those who have more stake to say what they think? Is it those who have spent more time? What is the truth? What is the definition of truth? That will impact the speed, right? And that will impact how much information do I need? Do I need a special blockchain that will be temporal and spatial constrained based on time and space? Let's say traffic lights. Do I need to carry that traffic information forever? So those questions, there is a big area of research in that is very active right now, yes.
So there's proof of work and then there's proof of stake, right?
Those are two of many. So we have proof of work, proof of stake, we have proof of time, we have a number of mechanisms of consensus. And again, this is a very rich area of research, because that means what is the truth for a community? This is a philosophical question now. Is it because the majority said so? Or is it because the loudest person said so? Or is it because the person who spent more time said so? What makes it true to disseminate it to the public? The algorithm, we can define what truth is, right? And that will impact the timing. So that's one big one, yes?
Could you go back to the slide that showed where Bitcoin has proliferated, the one with the map?
The which one?
The slide with the map, or the resource that you had that showed,
Oh, yes.
yeah, the world map.
Yes.
So I'm sort of noticing that there are clearly centers of
Yes.
territory miners. Is there a reasoning behind that, or like why it's so prolific in those areas and not in others? Especially in Europe and Asia.
I don't know, but I'll give you an example. A year ago, I was teaching that same exact slide in one of my classes. And at that time, the news mentioned that some Russian scientists went to jail because they used a supercomputer for mining cryptos. And then on the prior day, I have seen unknown, right? And then immediately after that news, 103 nodes went down. So we said, okay, maybe those are the guys. What is the rationale behind that? A number of things: the price of electricity, knowledge, know-how, because it's all about electricity. It's really expensive to run a mining machine right now.
And
Yes,
also,
please.
to respond to that, there are more of these miners and these bitcoins, cryptos issue in South Korea and Japan.
Indeed. Actually, this is a good example. Let me piggyback on this one. Already in Singapore, a company that is using already Bitcoin to promote engagement between youngsters, they have 280 million users already, where they are paying them with coin, and they are using this coin to get products from stores. It's called Jet 8, and it's a fascinating model. All of their marketing campaign are shooting to the roof, way better than anyone else. They have 40 blue chip companies that are already using them. So yes, in this case, in that area, it is more. Please.
Early on, you mentioned that I guess one of the things, the inspiration for blockchain was spam.
One of the components of the algorithm, it was Hashcash, yes.
So are there applications now that, like, I mean, I guess spam's still a bit of a problem, right? I mean,
It is.
blockchain applications in that, or? Yeah.
You see, the idea of proof of work came to fight spam. How is blockchain used for spam? Some of my students, actually, last year, they proposed an idea on the blockchain where they wanted to use blockchain for fighting fake news. So they try to prevent fake news by making sure that we know the source of the identity of the news, so that we clean up news that is real versus fake. At least we know the source of the news. So that was an exercise that some of our students here in our undergraduate did before. Are there existing commercial applications? I am not aware of. In the 4,300 companies, I'm not very sure.
Can you talk about a little bit about whether you got any real companies which rented space, taking these
Sure.
main coins from the main house?
Well, not yet. We already engaged with a local company here to implement a commercial solution. We already have a potential customer, which is the Chamber of Commerce, to hopefully use that solution. We are still in the experimental phase right now, but definitely this is our eye. We are not only looking at the SEC, but Mohegan Sun and other potential customers that can benefit from that in actual commercial application. Yes.
You also created some student businesses last year.
Yes.
In the class.
Every student, yes.
One or two examples of students?
Sure. One example, again, was the fake news. That was a good example. Another example was for some students who are actually trying to implement it in a nursery in the city. So it's a private nursery, and they wanted to have tags where the blockchain, you are a part of the blockchain with a tag. Then the parents can see if any stranger is near to your child.
Okay.
and then they can see that online. So that was one of the applications that is actually being tested right now in the city. The applications are major. What I'm really hoping out of this discussion is to promote the talking about blockchain. I already partnered with more than 7 of us in actual publications that were actually outside. So we are already strong. I would be very happy to work with you on pedagogical dimension to explain to your student if you wish. And I will be very happy to work with you if you have an idea that you want to bounce back. Let's get a cup of coffee and let's bounce ideas. And I think the opportunities are great and we are very well positioned to really make a difference, not only on the school level, but on the regional level. I really think so. Please.
Just a general comment. I know that, you know, like how we have a finance lab here. I know some schools across the country, I know like Duke has like a blockchain lab.
Yes.
So, I mean, that's, I don't know what they actually do. It's
yes.
certainly an idea.
For having labs, I spoke with our advisory board already, and all of those options are available. I really think the best case scenario would be to have a practical solution that is implemented in our business incubator. And once that is in, we can start rolling it out. Before we know it, we will become our lab. So before putting a big sign, I would rather giving products and then the sign will appear. Yes. But yes, I agree. Big universities are pushing for that one big time, yes. Guys, thank you so much for coming in. Please come in at any time. Thank you so much. I appreciate it. Thank you.